type of glass slab. Basically, you are just able to see only this portion. Only this portion you are able to see. Okay, this is a rectangular portion you can see. This is a rectangular portion. So that portion is drawn on this screen. So this is the portion. So what happens? This is the and here is air. This is the glass and this is air. So refraction will take place. This is the incident ray. This is normal, and refraction will take place. So after refraction, light will went towards the normal. Okay, and if there will be no glass slab, then path of the light should be straight line like this. This is straight line, and after that, here the refraction again on this surface, the refraction will take place. So here what will happen? Now the light ray, this light ray is emerging out or just leaving the glass slab and entering to the air. Means here the light ray is moving from denser to rarer medium. So what happens when a light ray moves from denser to rarer medium? It bends away from the normal. So basically it bends away from the normal, and final this angle is known as the angle of emergent. Angle of emergence. This no E is known as the angle of emergence. And this is a glass slab, and F1 and F2 are representing, you can see this. Okay, so basically this is one face of the glass slab and this is the another face of the glass slab. So F1 and F2 are the opposite faces, you can say. Okay, so but in case of a glass slab, in case of refraction through glass slab, incident ray. Okay, see, this is the incident ray direction, and see the emergent ray. Emergent ray means finally refracted ray are parallel. Okay, because opposite phase. And why these rays are parallel? Because of this shape of the glass slab. Because of the shape of the glass slab. So this face of the glass slab is parallel to this face of the glass slab. Is it or not? This face of the glass slab is parallel to this face of the glass slab. F1 and F2 are opposite faces and both are parallel. Okay, this is the emergent ray. So basically this is what happened, refraction through the glass slab. Okay, now what is E here? E is the angle of emergence. E is the angle of emergence. Emergence means light is emerging out from the glass. So that is why this angle is known as the angle of emergence. Okay, now after this, the glass slab, we will have a triangular glass prism. So basically this is a triangular glass prism. Maybe you have seen this in your lab. A triangular glass prism. See, this is a triangular glass prism. Basically this is a phenomena, dispersion of light we will study. Basically a white light when passed through a triangular glass prism. So due to the different amount of refraction, dispersion of light takes place. Okay, and white light is just split into the 7 colors we will discuss. So basically I want to show you what is the glass slab, what is the triangular glass prism. So this is a triangular glass prism. Okay, so on paper how we will show the glass prism? Like this. Only we draw one triangle like this. And basically how to draw in 3D if you want to imagine. So it is better to draw like this. Okay. Okay, so we can draw it. Like this, and like this. These are not looking parallel. Okay, no problem. So basically, so you can say this thing is a glass prism. Okay. This thing is basically a glass prism, and this is the phase 1 and this is the phase 2. These are the opposite faces. These are the opposite phases. Okay. And how this glass prism will be represented in diagrams, or when you will draw on your copy, you will just show like this. This is basically the representation. Okay, Azaan. And basically this is actually what the glass prism is in reality. So can you tell me how many rectangles are there in glass prism? Azaan,
Yes, sir.
can you tell me how many rectangles are there in this glass prism and how many triangles are there in this glass prism? This is basically a triangular glass prism.
Sir, three rectangles and two triangles.
Very good. Yeah, of course, right. One rectangle, another rectangle, and there will be one another rectangle at the base. Okay.
Yes, sir.
Yeah. And this is how we will represent the, okay, just turn off your mic. Okay. So basically this is how we will represent the glass prism in the triangular form. Basically, when you will suppose you are the observer here, and you are watching this glass prism from this side, so you will see only this face na, of the glass prism. So basically according to this observer, this figure is drawn. So this is the representation. Earlier what you have seen, when a ray of light is passing from the glass slab, so the incident ray and the finally refracted ray, or you can say emergent ray, are parallel. Why parallel? Because in case of the glass slab, the opposite phases are parallel. But now see here, these are two opposite faces F1 and F2 are the opposite faces. Are they parallel? No, these are not the parallel faces. These faces are like this. One face is this, another face is this. These are like this. So these are not parallel. Parallel faces will be like this. Okay. So as these faces are not parallel, so it is confirmed that the incident ray and the finally refracted ray will not be parallel. Okay. So now we will see what will happen when a ray of light will refracted through the glass prism. Okay. Uh, so this is just for giving you the feel, and basically representation of triangular glass prism I have already written. So this is, in this way you will represent this glass prism. Okay. So now see how the refraction through the triangular glass prism takes place. This is a triangular glass prism, PQR. We show a glass prism like triangle. So PQR is a triangular glass prism, and this is an incident ray, and this is glass here, and here is air. So now this is the interface between the air and the glass. So here the refraction will take place. Okay, so incident ray direction is this. Now this is the normal. Suppose this is N1. N1 is the normal. Okay, normal is perpendicular to this surface. Line perpendicular to this surface is normal. That is this line, or this is normal. So incident ray. So as the light ray is moving from rarer medium to denser medium, it will bend towards the normal. You can see it will bending towards the normal. So this is the actual path of the, not the actual, this is the path of the light when there is no glass slab in between. Okay, so after that, what will happen? This ray will be refracted from here, and this ray, suppose, going in this direction, and now here is the interface of glass and air. Here again the refraction will take place, and now this is the normal. That's how you will draw the normal. Suppose this is n2, normal n2 on the opposite face, okay, on the opposite face of the glass slab. So this is the incident ray now. This ray becomes the incident ray, and this is the normal. And what happens here? Ray is moving from denser to rarer. It will move. It will bend away from the normal, not towards the normal. Okay. Now you can see here. If the light ray is going actually, so this should be the path of the light. Okay. But it is bending away from the normal. Okay. Bending away from the normal. So basically, finally refracted ray is known as the emergent ray. And now you can see this is the incident ray, this is the direction of the incident ray, and this is the direction of the emergent ray. Both are not parallel. And this angle is known as the angle of deviation. Means how much amount the incident ray is deviated. Okay. So is measured by this angle theta. So this is the angle of deviation. This is the incident ray. This is the emergent ray. Okay. Now you can see here incident ray and emergent ray are parallel in case of glass slab because the opposite faces are parallel. But in case of the glass prism, in case of the glass prism, the incident ray and the emergent ray are not parallel. There is certain deviation. So you can just say in refraction through the glass prism, emergent ray is not parallel to incident ray. Obviously, we can see here also. Why? Because opposite faces are not parallel. Okay. What are the opposite faces? Here, PQ. Okay, just PQ is a line, not a face, basically. So just you can say PQ face, and basically this face and this face are not parallel. Okay. That is why there is certain deviation between the incident ray and the emergent ray, and you can say incident ray and the emergent ray are not parallel. Okay, so Azaan, please write down. So both these concepts should be clear to you properly. What happens in examination also? The examiner can ask you what happens when a light ray is incident on the glass prism or when on the glass slab. Azaan, have you seen the rainbow? Have you heard about the rainbow?
Yes, sir.
Okay. When completed, you can ask me to scroll down. Refraction means the bending of light.
Sir, scroll down, please.
Hmm. So if you will observe this glass prism from here, from this position, then it will look like this is in the form of the triangle. Basically, you can say this is a front view, you can say. And basically, this is the top view. From the top, when you will see the glass prism, triangular glass prism, it will look like this.
Sir, scroll down, please.
Hmm. Completed?
Yes, sir.
So what happened na, after this? Newton in the year 1665 had done an experiment. He took a glass prism and he took means somehow the sunlight or white light he passed through that prism, and he used one screen also. So on the screen he saw uh, seven colors, means not seven colors, means a pattern of seven colors. Okay, a pattern of seven colors he had seen on the screen. Okay, so from this it is concluded by the Newton that the sunlight or the light of the bulb uh, is made up of seven colors. And when a white light means, you can say, when a sunlight is passed through the glass prism. So basically, uh, that white light is split it up in different seven colors, seven different colors. Okay. So basically, this is the phenomenon known as the dispersion of light. Okay, dispersion of light. So this is uh, given by Newton. So he took a glass prism and passed a white light on the screen. He got seven band of seven color. Okay, and there is one more thing I want to tell you. Different colors have different wavelengths and different frequencies. Obviously, okay, like red color have the uh, uh, maximum, you can say, wavelength among the seven colors. So basically now we will discuss the dispersion of light. And what is dispersion of light? Uh, this is very simple phenomena. This is the dispersion. This is a prism, okay, and this is a beam of white light, or beam of white light can be sunlight or it can be from the bulb light. So basically, here is air and this is glass medium, and here is again air. Okay, so now from here, now you can see this light ray is basically what is happening here at this point. This is a single white light. After this point, this light is just splitting up into different colors. Okay, into different colors. Now see from here, red colors. This is our orange color. Means different colors. The light is splitting up. Okay, when it is passed from the prism, sunlight or white light. Okay, after passing through this surface of this means prism, splitting up into seven colors. Okay, now here again there will be the refraction taking place of the colors. Okay, so due to the refraction, due to the different, and now one more thing here. Basically this light is splitting up into seven colors. Why this is happening? Because on the screen finally you will get, basically Newton has done this experiment, passed the sunlight, and on the screen basically he got the seven colors like this, you can see here. I think I have removed that. So but what is the explanation for that? Why the red color is at the top, why the violet color is at the bottom? Why is this? Why the red color is least deviated? Why the uh, violet color is the maximum deviated? So basically, what happens when this white light is passed through prism? So what happens here? Splitting of light takes place, and splitting of light takes place, and after the splitting, you can say different colors have different wavelength, have different frequencies. So talking about the wavelength, red color has the maximum wavelength. Okay, red color has the maximum wavelength. Okay, so as this light is traveling now, this red color, now focus on the red color of this white light. This red color is traveling in the glass. Okay, this red color is traveling in the glass, and this orange color is also traveling in the glass. And we know that the speed of the light is different uh, in the same medium for different wavelength. Okay, means for different colors, the wavelength is different. Due to that, these colors suffer different amount of refraction. That is why the red color is least deviated. That red color is the least deviated. Why? Because the wavelength is large, and wavelength is large. So in the glass, the speed of the red color is more as compared to these colors. So basically, the splitting of white light into seven colors on passing through a transparent medium like glass prism is called dispersion of light. Okay, so this is a pattern you will get. Okay, on the top you will get red, and at the bottom of the screen you will get violet color. So you can just remember it with Vivgyor. It is known as Vivgyor. Violet, indigo, blue, green, yellow, orange, and red. So basically, uh, when you are moving from red to violet color, the wavelength is decreasing and frequency is increasing. So violet color has the minimum wavelength and red color has the maximum wavelength. Red color has the maximum wavelength. That is why this red color is least deviated. Okay. Why? Because the least amount of refraction is taking place for this red color after the splitting. So this is the reason I have written why all the colors are just deviated by different angles. I have already explained you. This is just a statement you can write in the exam. Reason different colors deviated to different angle of deviation. Why? Because they suffer different amount of refraction due to different wavelength. Okay, you can say the amount of refraction or bending depends upon the speed of color light in the glass. Speed is depending upon the wavelength. Okay, so since different colors travel with different speed in glass, so they are reflected through different angle. Some colors reflected least, for example red color, and some colors deflected maximum, that is violet. You can explain this with the help of the wavelength also. As the red color has the largest wavelength, so as the wavelength is large, so if the wavelength is increased, wavelength is large, so speed of the light is also large. So as the speed of the light is large, so there will be less refraction. Okay, so just okay, remember this thing. This is, I think, enough. And remember, red color is least deviated. Okay, you can note it. Red color least deviated. Violet color maximum deviated. So why this is happening? Because because red color have maximum wavelength. So this suffers least refraction, and violet color have minimum wavelength. That is why minimum means low speed. Low speed means more refraction wavelength. So try to relate all the things. Okay, Azaan. So just try to draw this if possible. Otherwise, you can draw a single ray of light like this, and you can just draw only the red color. And here you will show the screen, and here you will show the white color. Okay, I am telling how to just draw this thing. Okay, so basically this is the prism. Okay, this is the prism, and white light is coming like this. Okay, white light is coming like this. Okay, and from here what will happen? This will be splitted up into different colors. Okay. You can show only two colors. So show here one screen like this. Basically this color will represent the red color. This color will represent the violet color. Okay, this is least deviated. This is maximum deviated. And what is this? This is the white light. Okay, and what is this? This is normal if you want to draw. You can draw. And what is this? This is the screen. So in this way also you can just show this diagram. So it is better to try to draw the diagram in this way. Otherwise you can draw in that way also. So dispersion of light. Topic is dispersion of light. Dispersion means splitting of light into 7 colors. And now we know light is made up of 7 colors. Sunlight is a combination of 7 colors. And this is shown by the Newton by his experiment through a prism. Okay. Okay, note down. Hello, Azaan.
Yes, sir.
Can you tell me what is the reason of dif dispersion of light?
Yes, sir.
I'm just asking what is the reason of dispersion of white light?
Sir, like
Hmm.
when white light passes through the glass prism,
Hmm. Right.
its colors, like the seven colors, travel
Hmm.
with different speeds
Hmm. Okay. Right answer.
because the refractive
Ah,
index
you are
is
right.
color
You are right.
dependent.
Because the speed is different. Because okay, actually refractive index is for medium. Okay, so with speed, if you will explain, it will be better because they all colors are in the same medium in the glass.
Okay, sir.
But in the glass also, all the colors have different. All the seven colors have different speed, and due to that, they suffer different amount of refraction after passing through the prism. So that is why dispersion is taking
Okay,
place.
sir. Sir, scroll down, please.
Hmm. Okay, Azaan. So after writing this down, you can leave the meeting, and we will meet tomorrow. Uh, and tomorrow, which chapter should I start in maths?
Maths.
Probability.
Okay, sir.
Okay. So okay, after writing down this, okay, we will meet in the next class.
Okay, sir. Sir, I will take screenshot.
No, no, no. You can write.
Okay,
Actually,
sir.
we have time. We have so if
Okay, sir. Okay. Done, sir.